Picture this. You're standing in the middle of a desert where temperatures soar past 120 degrees Fahrenheit, where shifting sands have swallowed entire civilizations, and where the horizon stretches endlessly without a single landmark to break the monotony. Now imagine someone telling you that in this exact spot, they're going to build something taller than anything humanity has ever constructed. You'd probably think they were suffering from heat stroke. But in 2004, that's exactly what happened, in Dubai. And the man making this seemingly impossible promise wasn't just anyone. He was Sheikh Mohammed bin Rashid Al Maktoum, a leader who had already transformed a small trading port into one of the world's most ambitious cities. The year was 2004, and the world's tallest building was Taipei 101 in Taiwan, standing at what seemed like an insurmountable 1,671 feet. Engineers worldwide considered this the practical limit of human construction. The physics were clear, the challenges were known, and the consensus was unanimous. Going much higher was simply too dangerous, too expensive, and too complex. But Sheikh Mohammed had a different vision. He didn't just want Dubai to compete with the world's great cities. He wanted it to redefine what was possible. When he announced plans for a tower that would dwarf every structure on Earth, critics called it madness. Financial analysts questioned the economics. Engineers shook their heads at the impossibility, yet there was something deeper driving this vision than mere ambition. Dubai had always been a crossroads, a place where traders from different continents met to exchange goods and ideas. But in the modern era, it faced a sobering reality. Oil wouldn't last forever. The Emirates needed to transform their economy, and they needed the world to see Dubai not as just another oil-rich state, but as a beacon of human achievement and innovation. The psychological impact of this decision cannot be overstated. When you announce you're building the world's tallest building, you're not just making a construction promise, you're making a statement about your belief in human potential. You're telling the world that the impossible is merely difficult, and that vision combined with determination can literally reach new heights. Mohammed bin Rashid understood something profound about human nature. We are drawn to those who dare to attempt the impossible. Throughout history, the structures that capture our imagination aren't just the practical ones. They're the ones that seemed impossible when someone first dreamed them. The pyramids of Egypt, the cathedrals of Europe, the Brooklyn Bridge, each one faced the same skepticism that would greet Dubai's announcement. But here's what made this moment different. This wasn't about conquering new lands or establishing religious dominance. This was about proving that in an age of cynicism and diminished expectations, humans could still unite around a vision so bold it would take your breath away. Literally, as it turned out, since the final height would extend into the clouds where the air grows thin, the secrecy surrounding the project only added to its mystique. Unlike other major construction projects, the exact height of Dubai's tower remained classified. The architects and engineers knew, but they weren't talking. This wasn't just construction. It was a carefully orchestrated reveal that would unfold. Over 6 years of building, with the world watching and wondering just how high these dreamers would dare to go. As news of the project spread, something remarkable happened. Engineers who had never considered pushing beyond the established limits began sketching new possibilities. Architects started reimagining what skylines could look like, and ordinary people around the world found themselves following the progress of a building site in the desert, because deep down, we all hunger for proof that human beings can still achieve the extraordinary. The tower would eventually be named Burj Khalifa, but in those early days, it was simply called Burj Dubai, Dubai's tower. And in choosing to build it, Dubai wasn't just changing its skyline. It was betting everything on the idea that in a world grown cautious and calculated, there was still room for the impossible dream. What happened next would test every assumption about what humans could build, survive, and achieve. The question wasn't just whether they could build higher than anyone before, it was whether they could build something that would inspire the world to dream bigger dreams. Imagine standing on a cliff edge as hurricane-force winds threaten to tear you from your foothold. Now imagine that feeling, but you're not on solid ground. You're suspended nearly half a mile above the earth, and those winds aren't a temporary storm. They're a permanent, invisible enemy that grows stronger with every floor you climb higher. This was the nightmare that kept Adrian Smith awake at night. As the lead architect for what would become Burj Khalifa, Smith faced a terrifying reality that no human architect had ever confronted. At the heights they were planning to reach, the wind wouldn't just be an inconvenience. It would be a potential killer. The story of humanity's relationship with wind is as old as civilization itself. We've learned to harness it for sailing, for generating power, for cooling our homes. But at extreme altitudes, wind transforms from ally to adversary. At 2,000 feet above ground, wind speeds can exceed 100 miles per hour on an ordinary day. At that velocity, wind doesn't just push against a building, it can create oscillations that literally tear structures apart from the inside out. Smith's team knew they were entering uncharted territory, but they had no choice. The vision demanded they go higher than anyone before, which meant confronting forces that had never been fully measured or understood at such scales. Traditional rectangular buildings, the kind that dominated every major skyline in the world, simply couldn't survive what nature would throw at them at these heights. The first breakthrough came from an unexpected source of inspiration. While studying the way desert plants survive brutal windstorms, the team noticed something remarkable. The most resilient desert flora didn't fight the wind head-on. Instead, they used curved, flowing shapes that confused and redirected the wind's force. This observation would reshape not just their building, but the entire future of super-tall construction. But observation alone wouldn't be enough. Smith's team needed to see their enemy in action, to understand exactly how wind would behave around their unprecedented structure. This led to one of the most intensive testing programs in architectural history. Over 40 separate wind tunnel experiments, each one revealing new dangers they hadn't anticipated. Picture the tension in that testing facility as engineers watched. Scale models of their design shake, vibrate, and sometimes collapse under simulated wind forces. Each test wasn't just a scientific experiment. It was a moment of truth that could either validate years of work or send them back to the drawing board. The pressure was immense, because failure here didn't just mean professional disappointment. At the heights they were planning, a miscalculation could cost lives. The breakthrough came with the Y-shaped design, a revolutionary approach that no one had attempted at this scale. Unlike the rectangular towers that dominated skylines worldwide, this organic, flowing form would literally confuse the wind. As air currents hit the building, instead of creating the dangerous vortex patterns that could cause catastrophic swaying, the irregular surfaces would break up the wind flow, reducing forces by up to 25%. But even with this innovation, the engineers discovered something that would haunt the project's residents forever. No matter how clever their design, the building would still move. In high winds, the top floors would sway up to 6 feet in either direction. For the people living and working inside, this meant experiencing something no human in history had ever felt: the sensation of their solid, secure building gently, rocking like a ship at sea, nearly half a mile above the ground. The emotional toll of these discoveries cannot be overstated. Every engineer working on the project understood that they were responsible not just for creating something beautiful, but for ensuring that thousands of people could live and work inside their creation without fear. The weight of that responsibility was crushing. One miscalculation, one overlooked variable, and the consequences would be unthinkable. As the wind tunnel tests progressed, something remarkable happened among the team. The constant confrontation with failure, the endless iterations and improvements, forged a bond that went beyond professional collaboration. They weren't just colleagues anymore. They were fellow soldiers in a war against the fundamental forces of nature. Each successful test felt like a victory not just for engineering, but for human determination itself. The final design that emerged from this process was unlike anything the world had ever seen. The building would rise in a spiral, its form changing and twisting as it climbed, each setback and curve carefully calculated to manage wind forces that had never been encountered at such scales. It was beautiful, but its beauty came from a deeper truth. It was shaped by respect for nature's power and by an absolute commitment to protecting human life. What they had created wasn't just a building design, it was a new way of thinking about humanity's relationship with the natural world. Instead of simply overpowering nature through brute force, They had learned to dance with it, to find harmony even in the face of forces that could destroy everything they had worked to build. There's a moment in every impossible dream when you realize that success or failure will be determined not by what the world can see, but by what lies hidden beneath. For the team building what would become Burj Khalifa, that moment of truth came at 3 a.m. on a sweltering night in the Dubai desert when they began pouring concrete into a hole that seemed to descend into the Earth's very core. 50 meters down they had dug, deeper than a 15-story building is tall, carving through sand and rock until they reached soil that could bear the unimaginable weight they were about to place upon it. But as project manager Ahmad Abdulrazak stood at the edge of that massive excavation, watching concrete trucks line up like soldiers preparing for battle, he understood something that would haunt him for months to come. Everything they had planned, everything they had dreamed, everything that would rise nearly half a mile into the sky depended entirely on what happened in the next 72 hours. The mathematics were terrifying. The building they intended to construct would weigh 450,000 tons when complete. To put that in perspective, imagine trying to balance the weight of 75,000 elephants on a single point, then multiply that force by the leverage of extreme height. Even the slightest imperfection in the foundation could create microscopic shifts that would amplify catastrophically as the building rose, potentially causing the entire structure to lean, crack, or worse. But weight was only part of the challenge. Dubai's desert environment presented a unique nightmare that engineers in New York or Hong Kong had never faced. The city sits on sand that shifts with temperature changes, underground water that rises and falls unpredictably, and soil conditions that can vary dramatically within the span of a few meters. Building the world's tallest structure here wasn't just ambitious, it bordered on geological recklessness. The solution required something unprecedented in construction history: a continuous concrete pour that would last over 24 hours straight, involving more concrete than had ever been placed in a single pour anywhere on Earth. The logistics alone were staggering. Hundreds of trucks, thousands of workers, and a margin for error so small that a single mistake could doom the entire project. As the sun set on that crucial night, engineer Sarah Mitchell found herself walking the perimeter of the site, calculating and recalculating the timing. The concrete had to be poured continuously to prevent weak joints, but Dubai's desert heat meant they could only work during nighttime hours. If they couldn't complete the pour before the sun rose and temperatures soared past 100 degrees, the concrete would cure unevenly, creating fatal weak points that might not reveal themselves until the building was already occupied. The emotional weight of this responsibility was crushing. Mitchell had spent 15 years building her reputation as one of the world's leading foundation engineers, but nothing in her experience had prepared her for the pressure of knowing that thousands of future residents and workers would literally depend on decisions she made in the coming hours. One miscalculation in concrete mix, one delay in the pour sequence, one equipment failure, and the dream of reaching unprecedented heights would crumble before it ever left the ground. At midnight, the first truck began emptying its load into the massive excavation. The sound was unlike anything anyone on site had ever heard. Not just the rumble of machinery, but something deeper, more primal. It was the sound of human ambition taking physical form, of an impossible vision beginning its transformation into reality. But as the hours passed, problems began emerging that no one had anticipated. The sheer volume of concrete created its own weather system within the excavation, with temperature variations that threatened to crack the foundation from thermal stress. Radio communications became nearly impossible as the concrete absorbed and reflected signals in unexpected ways. Workers found themselves operating in an environment that felt more like a science fiction movie than a construction site. By 4 a.m., project supervisor Carlos Mendez realized they were facing a crisis that could end the project before it truly began. The concrete temperature was rising too quickly, threatening to cause expansion cracks that would compromise the entire foundation. The decision he faced was brutal: continue the pour and risk everything on an untested solution, or stop the process and abandon 2 years of planning and millions of dollars in preparation. The solution came from an unexpected source. A young engineer named David Chen suggested something that had never been attempted at this scale: embedding a massive cooling system directly into the concrete as it was poured. Using hundreds of miles of cooling pipes and industrial-grade refrigeration units, they would essentially air-condition the foundation from within, controlling the curing process with surgical precision. As dawn approached and the final truck emptied its load, the exhausted team knew they had achieved something unprecedented. They had created not just a foundation, but a feat of engineering that pushed the boundaries of what concrete could do, how large-scale construction could be managed, and how human beings could work together under impossible pressure. Standing on the edge of that completed foundation as the first rays of sunlight hit the desert, Abdelrazak felt something he had never experienced in his decades of construction work. It wasn't just professional pride or relief at completing a difficult task. It was the profound realization that they had created something that would outlast them all, something that would carry the dreams and ambitions of an entire civilization skyward. Everything that would follow, every floor, every challenge, every triumph yet to come, would rest on what they had accomplished in those crucial overnight hours. There comes a moment in every impossible journey when you look up and realize that the ground beneath your feet has become a distant memory, and the sky above still stretches endlessly beyond your reach. For structural engineer Maria Santos, that moment came on a Tuesday morning in 2006, standing on the 50th floor of a building that was already taller than most skyscrapers, knowing she still had over 100 floors left to climb. The foundation was complete, solid as bedrock beneath the desert sand. But now came the challenge that would test every assumption about what human beings could build. How do you support nearly 500,000 tons of concrete and steel while it reaches towards space itself, fighting gravity with every floor, every beam, every bolt that carries the weight of an entire vertical city? Santos had spent sleepless nights staring at structural drawings that looked more like abstract art than architectural plans. The traditional methods that had built every other skyscraper in human history simply wouldn't work here. At these heights, conventional steel frame construction would buckle under its own weight long before reaching their target elevation. They needed something revolutionary, something that had never been attempted on this scale. The solution they developed was called the buttressed core system, and it was as beautiful as it was terrifying. Imagine a tree trunk surrounded by 3 massive branches that spiral upward, each one supporting the others in a dance of structural interdependence. But unlike a tree that grows gradually over decades, this structure had to be perfect from the very first day, because there would be no second chances at these heights. As the building began its vertical climb, every day brought new challenges that pushed the limits of human endurance and engineering knowledge. The concrete had to be pumped higher than it had ever been pumped before, requiring pumps so powerful they could have supplied water to entire neighborhoods. The pressure was so intense that pipes would burst without warning, sending thousands of pounds of concrete cascading down onto workers below. Elevator engineer Robert Kim faced a problem that seemed insurmountable. How do you move people efficiently in a building so tall that a traditional elevator ride from bottom to top would take nearly 10 minutes? The solution required reinventing elevator technology itself, creating systems that could travel at speeds that would make passengers' ears pop, while maintaining safety standards in an environment where a cable failure would mean certain death. But it was crane operator Jake Morrison who perhaps faced the most harrowing challenge of all. His crane had to grow with the building, climbing floor by floor as construction progressed, until he found himself working at altitudes where commercial aircraft flew. Every morning, Morrison would ride an elevator to heights that made seasoned pilots nervous, then climb into a cab suspended in space with nothing but thin air between him and the distant Earth below. The psychological toll was unlike anything anyone on the team had experienced. At 100 floors up, the human brain begins to struggle with the concept of height. Depth perception becomes unreliable. The normal reference points that help us navigate three-dimensional space simply disappear. Workers reported feeling disoriented, dizzy, sometimes unable to function normally in an environment their evolutionary psychology had never prepared them to handle. By the time they reached 120 floors, something unprecedented began happening. The building started creating its own weather patterns. The massive structure was so tall that it actually affected local air currents, creating pressure differentials that made doors slam shut unexpectedly and windows rattle in their frames. Workers reported feeling the building sway gently in high winds, a sensation so unnerving that some refused to return to the upper floors. Santos found herself dealing with stress fractures not just in the concrete, but in her team. The constant pressure of working at the edge of human capability, where every decision could mean the difference between success and catastrophe, was breaking down even the most experienced professionals. She watched colleagues who had built skyscrapers around the world struggle with anxiety, insomnia, and a creeping sense that they were attempting something humans weren't meant to attempt. The breakthrough came when they realized they weren't just building a building, they were creating a new form of human habitat. Like early explorers venturing into uncharted territories, they were pioneers pushing into vertical space that no one had ever inhabited before. This realization transformed their approach from one of fear to one of exploration and discovery. As they passed the 140th floor, the team achieved something remarkable. They had created a structure taller than the Empire State Building, and they were only halfway done. The steel beams they were placing were so high above sea level that they existed in thinner air, where metal behaved differently, where weather patterns were alien, where the very concept of up and down took on new meaning. Standing on the 150th floor as the sun set over Dubai, Santos realized they had crossed an invisible threshold. They were no longer just building tall, they were building in a realm where human beings had never lived before, creating spaces that would challenge every assumption about how people could work, live, and dream at altitudes that touched the edge of the sky itself. The question that haunted everyone involved wasn't just whether they could finish what they had started, but whether human beings were truly ready to inhabit the vertical world they were creating, floor by floor, dream by impossible dream. If you're amazed by these engineering marvels, hit that subscribe button and ring the notification bell. We're just getting to the most incredible challenges. Like this video if you're learning something new, and let us know in the comments what engineering feat impresses you most so far. Share this with anyone who loves incredible human achievements. At 1,500 feet above Dubai's desert floor, construction foreman Hassan Al-Mahmoud received a radio call that would haunt him for the rest of his career. One of his workers, a skilled welder named Ahmed, had collapsed on the 120th floor, gasping for breath in air so thin that his body couldn't process what his lungs were trying to give it. This wasn't heat exhaustion or fatigue. This was something no construction site had ever dealt with before. Altitude sickness in the middle of a building project. The higher they climbed, the more the construction site began resembling a military operation in hostile territory. Every morning, workers would suit up not just with hard hats and safety gear, but with equipment designed for extreme altitude work. Some carried portable oxygen canisters. Others took medication to prevent altitude-related headaches and nausea. The simple act of showing up to work had become an act of physical courage. Logistics coordinator Patricia Chen faced challenges that seemed to defy the laws of physics themselves. Getting materials to the upper floors required a dance of cranes, elevators, and timing so precise that a single delay could shut down work for entire sections of the building. The concrete pumps pushing material nearly 2,000 feet vertically operated at pressures so extreme that equipment failures weren't just inconvenient, they were dangerous explosions that could injure workers hundreds of feet away. The weather became an enemy unlike anything construction had ever faced. At ground level, Dubai might experience a calm, clear day, but 150 floors up, hurricane-force winds could be howling around the structure. Workers would arrive for their shifts only to be told that conditions at their work elevation were too dangerous, forcing them to wait for weather windows that might not come for days. Crane operator Jake Morrison, who had become something of a legend among the crew, developed his own system for dealing with the psychological pressure of working at altitudes where passenger jets flew beneath him. Every morning before climbing to his cab, he would spend 10 minutes looking at a photograph of his daughter back in Toronto, reminding himself why he was willing to risk everything to be part of something that would outlast generations. The human cost of working at these heights became impossible to ignore. Dr. Sarah Williams, the project's medical coordinator, found herself treating conditions that didn't exist in medical textbooks for construction sites. Workers reported vivid dreams about falling, panic attacks triggered by looking down, and a constant sense of vertigo even when they returned home at night. Some experienced what she called altitude addiction, becoming so adapted to the thin air and endless views that ground-level life felt suffocating and claustrophobic. Communication itself became a survival skill. Radio signals bounced off the building's surfaces in unpredictable ways, creating dead zones where workers could find themselves completely cut off from ground control. Hand signals evolved into a complex language visible across the vast distances of the construction site. In this vertical wilderness, staying connected meant staying alive. The breakthrough that kept the project moving came from an unexpected source: the workers themselves. Despite coming from dozens of different countries and speaking different languages, they developed an unspoken brotherhood forged by shared danger and common purpose. Vietnamese electricians taught Bangladeshi concrete workers how to cope with altitude sickness. Pakistani steelworkers shared breathing techniques with Filipino crane operators. In the thin air above Dubai, nationalism and cultural differences dissolved into something more fundamental: human beings taking care of each other in an environment that constantly threatened to overwhelm them all. As they pushed past floor 140, the construction site took on an almost mystical quality. Workers reported that sunrises and sunsets looked different from that height, more vivid and otherworldly. The curvature of the earth became visible on clear days. Weather systems could be seen approaching from dozens of miles away, rolling across the desert like slow-motion tsunamis of cloud and wind. Al-Mahmoud often found himself standing at the edge of completed floors, looking out over a view that no human being in history had ever seen from a man-made structure. The entire city of Dubai spread below like a detailed model, while above the sky stretched endlessly toward space itself. In those moments, the fear and exhaustion would fade, replaced by something approaching reverence for what they were creating together. But even as they celebrated each milestone, everyone understood that the highest, most dangerous work still lay ahead. Every floor they climbed brought them deeper into uncharted territory, where the margin for error grew smaller and the consequences of mistakes grew larger. The question wasn't just whether they could reach their impossible goal, but whether they could bring everyone home safely from humanity's highest construction site. HVAC engineer Lisa Thompson stood in the mechanical room of the 76th floor, watching her breath form clouds in the frigid air, and realized she was facing a problem that no engineer in human history had ever encountered. The building she was trying to cool and heat wasn't just tall, it was so massive that it had begun creating its own weather patterns inside its walls. At these unprecedented heights, the simple act of breathing had become an engineering challenge. The air pressure differences between the ground floor and the upper levels were so extreme that elevators became pressurized chambers, and workers experienced ear-popping sensations similar to airline passengers during takeoff. Thompson's team wasn't just designing an air conditioning system, they were creating an artificial atmosphere for a vertical world that nature had never intended humans to inhabit. The water supply challenge pushed Chief Mechanical Engineer David Rodriguez to the edge of a nervous breakdown. Pumping water to heights approaching 2,000 feet required pressures so intense that pipes would burst like bombs if they failed. Traditional plumbing systems would have collapsed under their own weight long before reaching the upper floors. Rodriguez found himself designing a cascade of intermediate pumping stations, each one a marvel of engineering that had to work perfectly or risk flooding dozens of floors below. What kept Fire Safety Coordinator Jennifer Walsh awake at night wasn't just the obvious challenge of fighting fires at unprecedented heights. It was the terrifying realization that in the event of a major emergency, evacuating the building's occupants could take hours. Traditional fire department ladders became useless after the first 30 floors. Emergency helicopters couldn't safely approach the upper levels due to wind conditions and the building's unique shape. The people who would eventually live and work in this vertical city would be, quite literally, on their own in case of disaster. The psychological impact of these discoveries rippled through the entire team. Systems engineer Michael Chen began experiencing panic attacks when he calculated evacuation times for the upper floors. The building they were creating would house thousands of people in a space where traditional emergency response simply couldn't reach them. Every system they installed had to work perfectly because failure at these heights meant more than inconvenience. It could mean tragedy on an unprecedented scale. the electrical challenges defied every standard in the industry. Power distribution. Engineer Amanda Foster discovered that the building would consume electricity like a small city, but delivering that power to the upper floors required transformers and switching stations scattered throughout the structure like vertical power plants. The electromagnetic fields generated by this massive electrical infrastructure began interfering with radio communications, creating dead zones where workers could lose contact with safety coordinators below. As they passed floor 100, something extraordinary began happening that no one had predicted. The building started developing its own microclimate. Condensation patterns formed in ways that meteorologists couldn't explain. Air currents created by the structure's unique shape began affecting local weather for miles around Dubai. The Burj Khalifa wasn't just occupying space, it was changing the very environment it existed within. The breakthrough that saved the project came from an unlikely source: marine engineering. Walsh realized that their vertical city faced many of the same challenges as offshore oil platforms or cruise ships, isolated environments where every system had to be self-sufficient and redundant. They began designing the building's mechanical systems like a ship that happened to sail vertically through the sky instead of horizontally across the ocean. But the emotional toll on the engineering teams was becoming impossible to ignore. Foster found herself working 18-hour days, driven by the knowledge that a single miscalculation in power distribution could leave hundreds of people trapped in darkness at heights where rescue was impossible. The weight of responsibility for systems that had never been attempted at this scale was crushing the spirits of engineers who had successfully designed buildings around the world. Water systems engineer James Patterson made a discovery that changed everyone's perspective on what they were creating. The building's water pressure differentials were so extreme that they could actually feel the building moving in high winds by watching the water levels in tanks throughout the structure. They weren't just building a static tower. They were creating a living, breathing organism that responded to environmental forces in ways no structure had ever responded before. As construction approached the 120th floor, the mechanical teams realized they had crossed an invisible threshold. They were no longer just installing building systems. They were creating life support infrastructure for a human habitat in an environment where humans had never lived before. Every pipe, every cable, every ventilation duct was a lifeline that would determine whether this vertical pioneer settlement could sustain human life. The question that haunted every engineer wasn't just whether their systems would work, but whether they had anticipated every possible failure mode in an environment so alien that the traditional rules of building design simply didn't apply. When Rajesh Patel said goodbye to his wife and 2 young children in Mumbai before flying to Dubai, he promised them he would be back in 18 months with enough money to buy a small house and secure their future. What he didn't tell them was that he would be working at heights where the air was so thin that some days he could barely catch his breath, where a single misstep meant a fall that would last nearly 30 seconds before hitting the ground. 12,000 workers from 31 countries had converged on this single construction site, creating a vertical United Nations where Bengali welders worked alongside Filipino electricians, where Pakistani crane operators shared meals with workers from Nepal, Kenya, and Brazil. But as the building climbed higher, something unprecedented began happening. These men from vastly different cultures started developing a shared language of survival that transcended every barrier of nationality, religion, and social class. Site Supervisor Maria Gonzalez found herself managing what felt less like a construction crew and more like an expedition team exploring uncharted territory. The workers on the upper floors developed their own customs and rituals around safety that had never existed in construction before. They would tap each other's hard hats before starting shifts at extreme height, not just for luck, but as a promise that they would look out for each other in an environment where a moment's inattention could be fatal. The medical challenges pushed project physician Dr. Ahmed Hassan into completely uncharted territory. He wasn't just treating typical construction injuries anymore. He was dealing with altitude-related illnesses, psychological stress from working at heights that defied human evolution, and cultural health beliefs from dozens of different countries that all had to be respected while maintaining safety standards. His medical tent became a kind of United Nations of healing, where traditional remedies from villages in Bangladesh were discussed alongside the latest in altitude medicine. Communication became a life-or-death skill that went far beyond language. Barriers. Safety coordinator Jennifer Park discovered that workers had developed an intricate system of hand signals, whistle codes, and even rhythmic hammer taps that could convey complex safety information across the vast distances of the construction. Sita. When radio systems failed due to the building's electromagnetic interference, these improvised communication methods sometimes meant the difference between coordinated teamwork and dangerous confusion. The psychological toll of working at these heights began manifesting in ways no one had anticipated. Workers reported dreams where they were flying, followed by nightmares where they were falling. Some developed what psychologist Dr. Sarah Chen called height addiction, becoming so adapted to the adrenaline rush of extreme altitude work that ground-level jobs felt boring and confining. Others experienced the opposite, overwhelming anxiety that followed them home, making it impossible to sleep in regular beds that felt too close to the earth. But perhaps the most profound transformation was happening in the relationships between workers from different cultures. Rahman al-Zahra, a Syrian supervisor, found himself sharing evening meals with workers whose countries had complex political relationships with his own. At 1,500 feet above the ground, national boundaries seemed absurd. What mattered was whether the person next to you would catch you if you stumbled, whether they would share their water during the scorching afternoon heat, whether they would risk their own safety to help you if equipment failed. The building site became visible from space, a glowing beacon of human activity that astronauts on the International Space Station reported seeing during night passes over the Arabian Peninsula. For the workers themselves, this knowledge that their labor was literally visible from space created a sense of historic purpose that helped them push through the daily dangers and exhaustion. As construction passed floor 140, project manager Carlos Rodriguez noticed something remarkable happening during shift changes. Workers from different floors, different specialties, different countries had begun gathering in small groups during breaks, sharing stories about their families back home, teaching each other words in their native languages, creating friendships that bridged every conceivable cultural divide. The extreme environment had stripped away superficial differences and revealed something fundamental about human nature: our capacity to care for each other when facing challenges that no individual could overcome alone. The final floors would test every bond these men had forged in the thin air above Dubai. The work ahead was the most dangerous yet attempted in construction history, requiring levels of trust and coordination that could only exist between people who had learned to see each other not as foreigners or competitors, but as fellow travelers on a journey to touch the very edge of human possibility. On January 4, 2010, project manager Ahmad Abdel Razak stood on the highest man-made point on Earth, 2,117 feet above the desert floor, and felt something he had never experienced in 30 years of construction work: the profound silence that exists at the edge of space. Around him, the curvature of the Earth was visible. Below him, the entire story of human civilization spread out like a living map. And in that moment, he understood that they had done something that would change not just Dubai's skyline, but humanity's understanding of what was possible. The final statistics were staggering beyond comprehension. They had used enough concrete to build a sidewalk from New York to Chicago. The steel framework contained enough metal to stretch a quarter of the way around the planet. But numbers could never capture what this achievement truly meant for the thousands of people whose lives had been forever changed by touching the impossible. Construction engineer Maria Santos, who had spent 6 years calculating loads and stresses that no human had ever calculated before, found herself crying as she watched the final spire being lifted into place, not from relief that the project was complete, but from the sudden realization that she had been part of something that proved human beings could still dream beyond the boundaries of what seemed reasonable or safe. The building's completion triggered something unexpected in cities around the world. Architecture firms that had never considered extreme height projects began sketching towers that reached toward the clouds. Engineering schools saw enrollment surge as young people inspired by the Burj Khalifa's construction decided they wanted to be part of pushing human capabilities even further. The impossible had become possible, and that possibility was contagious. But perhaps the most profound legacy wasn't visible in the building itself. It lived in the hearts and minds of the workers who had created it. Rajesh Patel returned to Mumbai not just with the money he had promised his family, but with stories that his children would tell their grandchildren about the time their father helped build something that touched the sky. Hassan al-Mahmoud found that no construction challenge would ever seem insurmountable again after supervising work at altitudes where passenger jets flew beneath his feet. The techniques developed during construction became the foundation for a new generation of super-tall buildings. The wind engineering innovations were adopted by projects in China, Malaysia, and the United States. The concrete pumping methods revolutionized high-rise construction globally. The safety protocols developed for extreme altitude work became international standards that would protect workers on projects not yet imagined. Yet the building itself continued to surprise its creators. Cleaning crews discovered that washing the exterior required specialized equipment and techniques that took 4 months to complete. The upper floors experienced weather phenomena that meteorologists were still studying years after completion. Residents reported that living at such heights changed their perspective, not just literally, but emotionally, creating a sense of detachment from earthbound concerns that some found liberating and others found unsettling. Dr. Sarah Chen, who had studied the psychological effects on the construction workers, began receiving calls from researchers around the world who wanted to understand how extreme height affected human behavior and cognition. The Burj Khalifa had inadvertently become humanity's first laboratory for studying how we adapt to life at the edge of our atmospheric envelope. The building's influence extended far beyond architecture and engineering. It had proven that in an age of cynicism and diminished expectations, human beings could still unite around visions that seemed impossible. The international workforce that had created it returned to their home countries carrying not just technical knowledge, but a shared understanding that cultural differences dissolved when people worked together toward something larger than themselves. As night fell over Dubai and the Burj Khalifa's lights began to twinkle like a vertical constellation, structural engineer Lisa Thompson realized that they had created more than just the world's tallest building. They had built a monument to human aspiration itself, a physical reminder that the word impossible was just another engineering challenge waiting to be solved. Standing in the shadow of their completed achievement, the team members who had survived the 6-year journey to the sky understood something profound. They had not just changed the Dubai skyline. They had expanded the boundaries of human possibility, proving that when vision, determination, and international cooperation combined, there were no limits to what humanity could achieve. The question was no longer whether taller buildings could be built, but whether the world was ready for the next generation of dreamers who would look at the Burj Khalifa and say, as they had once said about every previous record holder, "We can go higher." The Burj Khalifa stands as humanity's greatest vertical achievement, but it won't hold that title forever. If this incredible engineering story inspired you, smash that subscribe button for more amazing construction and engineering content. Give this video a thumbs up if you learned something incredible, and share it with anyone who appreciates human ingenuity. What do you think will be the next impossible engineering challenge we'll conquer? Let us know in the comments below, and don't forget to hit that notification bell so you never miss our latest engineering adventures.